It has been a while since I've made a good old-fashioned cluster repair video, jackpot style. I think I have one. This is a board sent in by another cluster repair technician that does repairs and custom work. And when he runs into a jackpot, he'll send it my way. So do we have one? Just kind of just a surprise that showed up. We'll see if we can figure out what's going on and why it was sent here. I can see already this cluster is telling me some stories. It has probably been gone through, let me zoom in a little bit here. This has probably been through several hands, probably multiple. I see it's got the bent up vacuum fluorescent display pins from that little hole slot that's in the plastic. People think you're supposed to shove something in there to release the lens, and you're not. You're supposed to release the lens from the top first. Anyway, so a lot of times I'll see these pins all bent up right here and here from people shoving things in there. It's got the 50/50 LEDs, which I'm not a fan of. These, in my experience, are the most unreliable out of all the LED options. They have a nice wide angle and they're bright, so they look good, but they don't have a very long life. See, these are the, let me zoom in on this. That's a 50/50 LED is usually what the name they go by. So since this cluster has already been through the hands of a repair technician that is experienced with the clusters, the GM clusters, I suppose I should probably start from the top. This is a 2003, you can tell from the glass diodes, full-size Chevy instrument cluster board. And this is all I was sent. I wasn't sent the rest of the plastics and stuff, which is fine coming from another technician because they have the ability to properly calibrate it. Usually I prefer to get the whole cluster in, but in this case, it's fine. So what I was saying was, since this has already passed through a technician, a lot of the normal common stuff that needs to be reworked has already been reworked. So I see a lot of these common failure joints have been reflowed, which is good. It already has the X27s. Okay, that's great. The back, there's no silver migration corrosion, so that's already been cleaned. There might be a thin coat of conformal coating on here, really thin. I can't tell if that's just leftover flux residue or if that's a really thin coating, but it doesn't matter. I don't see any silver migration corrosion, so we don't have to worry about that. I see the connector pins have been messed with. There's 2 pins connected here. I think this is the bus in and out, so that is probably okay, but I want to take a closer look at that. But yeah, I can see these have been reworked. Under most conditions, these are actually not the problem. They get a lot of blame for the cause of the problem, but the only time these joints fail is when someone's really reefing on the plug. All right, back at the front side. So, all right, so it's got LEDs, it's got X27s, it's got a lot of reflow joints. Looks pretty good. Just power it up and see what happens. Oh, I do see it's got this extra colored film here over the vacuum fluorescent display. This changes the color, so it's not green. It probably makes it white, I suppose. We'll find out when it powers on what color that blue makes the green. Power it up. And got blinkers. Don't worry about the flashing. This is the check engine light. My connector's a little worn, so sometimes the lights will flicker. Blinkers, LEDs. So I'm not sure what this light is in the corner. I'll have to look. Okay, so we have no microprocessor life. Just some analog stuff is coming on. All right, so what I will do next is verify power is going to the places that power is supposed to be going. Let me just get my multimeter going on here. Sorry if you hear the cat meowing in the background. That's just the world's most annoying cat letting us know he's here. Trying to get my ground on my ground. All right. So I'm set to volts. So what happens is power comes in through the connector and it comes up to these diodes first over here. Let me come on in. Let's get a little closer view here. Power comes up to these diodes, so we should see 14 volts. Actually, all 4 of these glass diodes should see 14 volts. Sorry for the bad angle here. I'm trying to get everything into view. So we should see 14 all across the top, or 13, 12, whatever you have your power supply set at. My ground came off. I know I could put a banana plug on there, but I'm not going to. 13, good, good, good. And the last diode, we're missing power. There should be power here. So one of these diodes is for the continuous 12-volt battery, and the other is one of the ignition circuits. And this last one here is missing, which probably just means there's a problem between the connector and the top of the diode. But what we can do, I'm just going to steal some power from this first diode and send it over to the second diode. Oh, I hear something. There it goes. Okay, so actually that looks and sounds pretty good. It looks like we just have to chase down why this diode's missing power. I'm gonna take a closer look at that connector. I think that's, I think whoever reworked that connector maybe accidentally tore some foil or something. Let's find out. So this is where we're missing power at the top of this diode, and it comes from this second pin from the right here. So somewhere between here and here we have something damaged. And here's one more look at the previous rework job on the connector. I just want to take my desoldering gun and just suck up all the blobby joints here and see what's hiding. We will see what is hiding under those blobs. I have a feeling there's some damaged foil traces. Okay, I left these ones alone because these are all original. They're not all blobby. They haven't been reworked. And the pin that we're having trouble with is this one here. So doesn't look bad, but I'm going to use the microscope to really get a view on that. And like I mentioned before, a lot of times this connector gets a lot of blame when a lot of times it's not the problem. And let me explain what I mean. So this is the normal situation of what happens. Someone has a 2003 or a 2004 full-size GM vehicle, and their cluster is intermittent and it stopped working. And what they do is when they go to take their dash apart and when they go to unplug their instrument cluster, they notice that when they come back around to grab this plug and start pulling on it to remove the plug, boom, it all of a sudden it pops to life. And like, oh, I moved the connector, it started working, it must be a bad connector, right? I mean, that makes sense. Yes, but what's really happening is this connector is hard mounted to the board. It's a rigid mount connector. So when you move the connector, you're flexing the entire board. So what really is happening is you have fractured joints over here where the power is coming in, you know, before it hits the regulator. People are reefing away on this plug, trying to get it unplugged. It pops to life. But what is really happening is they're flexing the entire board. So these fractured joints are now making a connection as they're flexing the entire PCB. That's why it pops to life. Not because the connector's bad, but because you have fractured joints over here and the whole board is flexing. So thanks for coming to my TED Talk. Anyways, back to the connector. Let me see what's going on over here. Getting a close look at these pads, and I don't see any damage, no rips or lifted pads, so I'm just going to go ahead and use this as an opportunity to put down some nice solder joints. Just using some 91% ISO here to clean up the flux. And right here is where the solder jumper was, which I removed. This is where the class 2 bus comes in and out of the cluster, and sometimes when bad things happen on the output side with the bus, the cluster acts as the fuse, and things like this happen. So I'm just going to run a jumper across this to replace the blown trace. Bear in mind, this jumper can carry more current than that trace that was blown, so if something bad happens again with the bus on the output of the cluster, it's possible that something else will act as the fuse. Now onto the top side of the board. Since I didn't really see anything suspicious on the back, I'm going to take a close look at this diode and take a look underneath and see what's going on. And here I see some corrosion under that solder joint. Perhaps at some point in time somebody used a corrosive flux or a solder with a corrosive flux in it. So I'm just going to clean up this corrosion, see if we can get a good solder joint. I really want to make sure this joint holds and takes, so I'm just giving a little extra heat and solder. Just a bad joint hiding under a diode. Let's find out if that's all it was. It was a little crusty looking under that joint, and powered up. Hey, it is back to life. Well, I guess I was wrong. It wasn't a problem in the connector area. It was just a bad joint, and that diode had already been reworked. It already had been reflowed, but hiding under the solder joint was just a garbage joint, just a bad joint. So it looks like we're back to working. Is it not registering every click here with the trip button? It is a little leggy. Takes a little extra effort to, yeah, I really got to push on the trip button to get it to register. So if I just give it a normal click, it's not changing the option, so I really got to refund. I think I'm going to replace that while I'm at it, and I think that might be all it needed. I do see some of these warning lights have been resoldered back on. I want to make sure those are gonna work, like this one. Let's see here. Yeah, looks like maybe those are the two. These all look like original solder joints for these warning lights. Check engine light looks good. These look normal. Just this one and this one have been either replaced or reworked for some reason or another. So I just want to make sure they're good. Looks like all the LEDs are working. I'll make sure the stepper motors are each working, but for now we're on the right track. I'm going to start with replacing that trip button since it's not working very good. This is a tactile clicky button that I'll be putting in. It's a little bit more robust than these original mushy GM ones that they put in. Normally what happens with these is when someone has taken apart their cluster incorrectly, when they're taking the lens off from the bottom first, usually it ends up coming off kind of violently, and there's a trip button stem coming down from the face, and it has a little cup area around it. It kind of cups the switch with this stem for using your trip button. And when you take the lens off wrong, from the bottom up, what happens is as it kind of releases, it kind of jams the cup of the stem of the button into the top of the switch and actually breaks it off. So another important reason for removing the lenses the correct way. I see it done wrong a lot of times. But anyways, I'm going to put the part number for the tactile clicky switch down in the description. If I forget, please let me know. But if you ever work on GM clusters, yes, you're going to need some of these around because people love to break them. I'm just going to slap a little flux down. Got both the soldering irons fired up. You can use hot air for this, but I don't know. I kind of like just plucking them off with 2 irons. A little less collateral damage than blasting the area with heat. Nothing wrong with hot air, but I don't know. I just like doing it this way. Oh, come on now. It should be releasing. Both of my soldering irons are up to temp. What is going on here? There it goes. I don't know why that gave me such a hard time. All right. Microscope time. There is the new button. Got a nice tactile click now. Now it should register every click. Just gonna give it a chance to kind of boot up. There we go. There, trip, odometer, okay, or hour meter, I'm sorry. But yes, now it's registering every click. So that's good. And again, here is the original button that I pulled off the original. They're kind of fragile. They don't take much to break, but this is the trip button stem that sticks up out of the cluster. I just wanted to show you what I was talking about. So what will happen is when the lens is kind of forced up, this will, see how it kind of cups around, the spring kind of cups around the button. But if you jam this up, it catches the top of the switch and breaks it off. So not super often, but it's pretty common for me to see a cluster that has come in that has been previously worked on by somebody who really wasn't sure what they were doing. A lot of times they have the top of this trip button broken off, and then their trip button no longer works. Anyways, enough of that. Let me just make sure these LEDs that were removed or reworked or replaced, just want to make sure those are going to work. I'm just going to use diode check mode on my multimeter. I'm going to dim down some of the lights here. There's usually just enough power from diode check mode to light an LED. So let's try that right now and zoom in. So this is one of the LEDs right there. You see how the solder joint's kind of not original. I just want to make sure that, yeah, look at that. Oops, sorry, you're not in view. Why aren't you looking? Get over here. See, look, it works. Okay, so that one's good. I want to make sure the polarity's right, because just because it works doesn't mean it's soldered in the right direction. I'll double check that too. And this one right here has also been reworked, and that works too. We got an orange one here that's working and a red one here. Let me just make sure the polarity's right. Okay, so here's an untouched board to my right, and the board we're working on to the left. I'm looking for the notch. God, my eyes are just not what they used to be. I have to use the microscope. Okay, I just cheated. Yeah, so negative side is up, and that is correct. Polarity is right. On. Okay, yeah, so both of these LEDs that have been reworked are correct. They're in the correct direction and they work, so I don't have to worry about those. I think this one's done. I don't see anything else wrong with it. Yeah, the rest of the reflow joints look passable. There was just that one joint that was kind of hiding under the good solder, was a crusty joint. Maybe I'll double check these off camera. I don't know. I think we're done for the video though. It's working. Thanks for watching. Appreciate all my subs and all that for everyone that comes by. And hopefully this video is helpful for somebody. Okay, have a good one.